Okay guys, please make sure to pick up the notes, the 11.4 conditional probability notes. You guys will be able to find the conditional probabilities using tables and tree diagrams today. So some vocabulary that you'll need to know. Conditional probability is the probability of something occurring given something else already occurred. So the probability that you are going to get stuck by a train when you left the house late to get to school. That would be a good example. The probability of B happening given A has already happened. It exists when two events are dependent of each other. A contingency table is a two-way frequency table, and it contains data from two different categories. So sometimes, you might have like males and females. You might have, dogs, cats. You might have paper money versus coins, that kind of stuff. So there's two ways to find conditional probability, and that is to use a contingency table or use a formula. Okay, so these are all about using a contingency table for this portion. So this shows students by gender and by type of school in 2005. You pick a student at random. Before we do any kind of question like this, just like our marble questions or how many, markers in a bag, that kind of stuff, we need to add up our numbers here. So we are going to add down both of these directions, and then we're going to add across for all three categories. So the number of males there are is 7,539. The number of females in thousands would be 9,933. And I'm just going to add these two together. So we have 17,472 students total. Then I'm going to add across here. So for two-year colleges, and I don't have a ton of room here, that would be 4,328 students. In four-year colleges, there are 9,841 students. And then in graduate schools, there's 3,303 students. So we're going to add those all up. So then for the first one, what is the probability that a female is in graduate school? So what I kind of like to think about this is out of all of the kids that are in grad school, so that means out of all the kids that are in grad school, which is 3,303, how many of them are females? There are 1,954 females that are in grad school. So we're going to put that in our calculator, and we're going to get 0.59158, which again, you can leave it as a decimal, you can leave it as a fraction, or you can put it as a percentage, which would be approximately 59.2% of these students are females in grad school. So then on to the next one. Okay, so now we have everything added up for us on our table here. So second one is the probability that you have graduate school and they are female. So the probability of the kids being in graduate school given they are a female. So basically, again, you want to say out of all of the females, how many of them are in grad school? So we're kind of like working backwards in a sense. There are 9,933 females, and out of those, 1,954 are in grad school. So that would be 0.1967. And then if we round, we would get, let's round that up to 20%. Actually, no. Let's do not a laser pointer. Let's do 19.7%. Okay, then what is the probability that the student is just female? So out of all of the students, how many of them are females? So we're going to have 9,933 out of 17,472, which would be 0.5685, which is approximately 56.9% of students are females. Girl power. Okay, so now I want you to go ahead and complete number 2. Once you are done with it, you can go up and get the answer key and check your answers. Please do not go check your answers without trying these first. I'm going to help you out here. We're going to add up all the recycled, all the not recycled, and then we're going to add across for the types of materials. So these are our numbers, and I want you to complete those problems and check with the answers up front. So I'm just going to click through these until we get to the next part. Using the formula to find conditional probability. So our formula is for any events A and B with the probability of A not equaling 0. So we have the probability of B, given that A already happened, is the probability of both over the probability of A. And I want you to make sure you write this down. A and B are not independent events. Okay, which means that they are not going to happen at different times. Okay, so 3A, I roll a 6-sided cube. What is the probability that it lands on 5 given it lands on an odd number? So the probability of both a 5 and an odd number. So it has to be both of those at the same time. The probability of that happening is 1 out of 6 because you can only have a 5 and an odd number at one roll, which is the number 5. Then we have the probability of it being odd on the bottom. Probability of A, this one is A because given it lands on an odd number. Probability of A happening, which is an odd number. So our odd numbers are 1, 3, and 5. So that's 3 out of 6. Now think back to complex fractions. Remember, if it looks like this, we can change it into a division problem. And then we can multiply by the reciprocal. And what ends up happening is our denominators sometimes cancel, and then you're left with 1 over 3 as your answer, or 0.333 repeating, or 33.3% probability that you roll and you would land on an odd number, or lands on a 5 given that it lands on an odd number. So again, your odd number portion is A, landing on a 5 is B. Because it says given, our B comes first, our A is second. Okay? So then the next one, a spinner has equal sections labeled 1 through 20. What is the probability that the spinner lands on a multiple of 3 given the number is less than 13? So the number being less than 13 is our A, multiple of 3 is our B. Okay, so our probability for the first one is both a multiple of 3 and less than 13. So you can write down the numbers if you want. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the probability that the spinner lands on a multiple of 3 given the number is less than 13. Okay, so the numbers that are less than 13 are 12 on, because it doesn't say equal to 13. So how many of those numbers are both a multiple of 3 and less than 13? So 3, 6, 9, and 12 are all multiples of 3. So that means my top one is 4 out of 20 numbers are both of those, less than 13 and a multiple of 3. Then on the bottom, that is where I do the probability of the number being less than 13. So I have 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that is 12 numbers out of 20 that would be less than 13. So again, you can rewrite it as a division problem and then rewrite it as multiplication. Your 20s cancel because you're just multiplying across, it's cross canceling. And then you have 4 over 12, which if I divide both the top and the bottom by 4, I reduce that to 1 over 3, which is 0.333, which is 33.3%, same as 3A. Now, that's not always going to be the same, but sometimes it works out like that. Okay, so I want you guys to do 3C and the next one, the other you do. So I draw a card from a deck. What is the probability that I draw a 4 given it's a diamond? Set it up like I did. There's 52 cards in a deck. And then I want you to go back and check or work for 1A using this specific formula. So I already put in the numbers for you, and I have the table up here so you don't have to flip back and forth. Once you finish those two, go up front, check your work with my key. Okay, I roll 2 regular 6-sided dice. What is the probability the sum of those dice is 7, given that one of the dice was a 2? Okay, so I can roll, let's do a 1, a 2, a 3, a 4, a 5, and a 6. So I need to think of the pairs here. So if I roll a 1 for my first die, then in order to add to 7, I need a 6 for my second. For my first die, if I roll a 2, I need a 5 for my second. If I roll a 3, I need a 4. If I roll a 4, I need a 3. If I roll a 5, I need a 2. If I roll a 6, I need a 1. So the only 2 options that I can use here that have a 2 is 2 and 5 or 5 and 2. This we kind of need to think back to our last, the last set of notes where, you have 2 dice, right? So that means you have 6 sides times 6 sides, which means you have 36 possible outcomes. Okay, and that is what our choices are going to be out of. So the first one is the probability that it is both a sum of 7 and the die is a 2. So we have 2 out of 36 options there, 2 and 5 or 5 and 2, to add up to 7 and having a die that is a 2. The probability that the die is a 2 is 11 out of 36. Because we can either roll, we can roll a 1 and a 2. we can roll a 1 and a, or we can roll 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, and so forth. Then the next one, we could roll a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, a 2 and a 6. The next one, then, we could roll a 3 and a 1, a 3 and a 2. So this one would have all of these. This one would only have 1, this one would only have 1. Then we could roll a 4 and a 1, a 4 and a 2. That's another. We could roll 5 and a 1, 5 and a 2. That's another. And then we'd also have a 6 and a 1, 6 and a 2, and that's another. So if you count up all those, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we would have 2 over 36 over 11 out of 36. So 2 out of 36 divided by 11 out of 36. Again, we're going to switch it, make it multiplication. And then cross cancel the 36's. So we have 2 over 11, which would be 0.1818, which is 18.2% chance, which is pretty high. Okay, so now we have using a tree diagram. So a school system compiled the following information from a survey sent to its past students. 85% of the students graduated from high school. Of the students that graduated, 90% are happy with their job. Of the students who did not graduate, 60% are happy with their job. Draw a tree diagram to answer the following questions. Okay, so first of all, we need to add in some values here. Okay, so I'm going to get to the next one. Oh, okay, you can add this in first. So the percentage or the probability that you graduated was 0.85. Of the students that graduated, 90% are happy with their job. So we're going to put a 0.9 for happy with their job. So each of these little sections needs to add up to 100. Okay, so if 85% graduated, 100 minus 85 is 15. That's why we put the 0.15 here that didn't graduate. And then this has to add up to 100, this has to add up to 100. So each branch needs to add up to, each little branch type thing needs to add up to 100. So if we have 0.9 that are happy with their job, that means 0.1 are unhappy with their job. Of the students who did not graduate, so that 0.15, 60%, so 0.6 are happy with their job, and 0.4 are not happy with their job. So I want you to write that down on your paper there so that you can get that for the next question. Okay, so before I do anything, I want to point out that each second branch represents a conditional probability. So the probability that a person is happy given that they graduated is 0.9. The probability that the person is not happy and they graduated is 0.4. Is 0.1. Okay, so you can kind of look at some of these answers on the tree, but for A, it's asking you for the probability that they are graduated and happy. The and is important here. Remember back to multiple events where if we see the word and, it means we're going to multiply. So we're going to multiply the probability that they graduated, which is 0.85, and multiply the probability that they are happy, which is 0.9. And this would give me 0.765, which is a 76.5% chance that they are graduated and happy. 4B, so again, this is written in a different way. So not happy is our B, and not graduated is our A. So that means, out of all of the people that didn't graduate, how many are not happy? So this is given in the end of the tree. We already know that they didn't graduate. So we can just use our 0.4, which is 40%. For 4C, again, you can use the formula if you want. So this is asking, out of all of the unhappy people, how many of them are graduated? Okay, so we are first going to say the not happy people on top. So the people that graduated, which is this, and the not happy with their job, which is this. So on the top, we're going to have 0.85 times 0.1. On the bottom, we are doing the probability that they are not happy. Okay, so this is where it gets a little tricky. So we're going to have this option here, and then this option here. So we're going to add up the probability of the two. So 0.85 times 0.1 plus, because they can be graduated and not happy, or they can be not graduated and not happy. And that's why we add the two, because it's graduated or not graduated. So on the top, we're going to have 0.085. On the bottom, we're going to have 0.085 plus 0.06. And you can just plug this all into your calculator if you want. When I add the bottom together, I get 0.145. And then when I divide those two, I get 0.5862, which would give me 58.6% chance that given that they are not happy, they graduated. Okay, then I want you guys to try these next two, so 4D and 4E. Check your answers with mine for the answer key. And then the challenge part is happy. What is the probability that they are happy? So we are going to take, okay, they graduated and they are happy, or they didn't graduate and they are happy. So this is kind of a multiple event situation, so they can do one of the two. They can graduate and be happy, or they cannot graduate and, whoops, let me erase that here, or they can graduate and still be happy. So 0.5 times 0.9 is 0.765. 0.15 times 0.6. I think I did this wrong. 0.5 times 0.6. 0.15 rather. Would be 0.009. So if I add those two together, I get 0.774, which is 77.4% chance that they are happy. Once you check your answers, you can go ahead and grab the practice sheet. Please make sure that you do your other homeworks that you are missing If you didn't finish the stuff from yesterday, you can work on that and turn that in as well. Have a good weekend, guys.